quadratic factors. Yesterday they were all linear. But today we do contain quadratic factors. So when we split up with quadratic factors, and this is a combo, so there's still a linear factor in the denominator and a quadratic factor. If it's the linear factor, it's still just a that goes over it. And a is a constant, right? So if the denominator is linear, the numerator is just a constant. But if the denominator is a quadratic, the numerator is 1 degree less, which would mean the numerator needs to be of a linear format. So it won't just be b, it'll be bx plus c. That's like your mx plus b format. That's a linear factor. Do we follow that? And you just hit the next two, capital A, B, C that you get to. Does that make sense? So when we clear fractions, we multiply both sides by this so that that will cancel. And when we take this and distribute it to your A, your x minus 2's cancel. When we distribute it to the bx plus c, the trinomial cancels. But be careful here because it's not just a constant anymore times what's left over. It's the bx plus c times the x minus 2 that did not cancel. So there's a little more distribution here. So the a is fine. Ax squared plus 2ax plus 4a. But over here we have to FOIL bx squared minus 2bx plus cx minus 2c. And then, just like we did with the others, we start combining. So we need how many x squareds total? How many total do we have on the left? 3. So a plus b needs to equal 3. That covers that. We need 17 x's. So there's a 2a minus 2b plus a c. And then your constants of 4a minus a 2c has to be 14. System of 3 variables again. So we can either take advantage of the fact that the c is already gone in the first, or take advantage that the b is already gone in the third. Let's just say I'm going to take advantage of the fact that the c is already gone. So a plus b equals 3. And then in the second two, since the c was gone already and that's what I'm taking advantage of, I want to eliminate the c down here. So this needs to be multiplied by what? 2. So that would create, I'll go this way, 4a minus 4b plus 2c equals 34. And then 4a minus 2c equals 14. And am I adding or subtracting? I was trying to eliminate the c. So even though my a's happen to be the same number as well, remember that our goal was to eliminate c. So we just had a's and b's left. So adding, opposite signs add. So that's going to give you 8a minus 4b equals 48. So I'll line that up under my other AB equation. Normally we use multipliers. Have you ever just divided out of 4 to shrink it down? So that would just be a plain B. It's an option. You can multiply the top by 4, or you can technically multiply the bottom one by 1/4. And that would make the top stay the same, and dividing by 4 would make that 2a minus b equals 12. Add or subtract? add. Opposite signs on the b's, add. So that gives you 3a equals 15, a equals 5. Go back, 8, well, I'm going to go to the top one, this one. A is 5 plus b equals 3, so b equals negative 2. And then go back to maybe your easier version of the original 3. 4a's will be 4 times 5 minus 2c equals 14. Subtract 20 from both sides. Negative 2c equals negative 6. And c is 3. Remember, that is not your answer. So on your quiz tomorrow, don't stop there. Write out what the decomposition actually looks like. So go back up really to the structure that you started and replace the a accordingly, the b, and the c accordingly. So this one will be 5 over x minus 2 plus your bx plus c is going to turn into negative 2x plus 3 over x squared plus 2x plus 4. So one thing that you'll notice if you check your answers in your back of your book, they usually still don't like to start that with a negative. But why can't they just bring the negative here and just make it 5 over that minus 2x plus 3, Olivia? Right, so they'd have to, like, if they just had a minus there with a 2x plus 3, technically you'd have to distribute that negative and you wouldn't be the same. So what they'll do is they'll factor a negative out of both of those. So it's minus, and then your numerator is 2x minus 3. And that's the same thing. So if you see that in a multiple choice, or if you see that when you check your answers in your back of your book, that's why. Okay? In the next one, similarly to last night, I'm showing you an example of a quadratic factor that's being raised to the second power. So the factor that's inside the parentheses is certainly quadratic because there's a squared on that, but then it also has a degree more than 1. So just like we did yesterday, we have to work our way up to that. So this will equal ax plus b over x squared plus 1. So because that's a quadratic factor, the numerator has to be linear in nature. And then we work our way up to the denominator being x squared plus 1 squared, which is still a quadratic factor, so we need a linear structure up top, so we're just going to hit c and d. Cx plus d. So same idea, it just gets a little more complicated because it's binomials up top instead of just a, b, and c. So I'm going to multiply both sides by this to clear it. So x squared plus 1 squared. When I distribute to the ax plus b, only one of those x squared plus 1's cancel, so it's ax plus b, which it's now appropriate to put that in parentheses because you're going to multiply it by the leftover x squared plus 1. And then when you distribute to the cx plus d, the whole thing cancels. So you're lucky enough not to really, if you want to keep parentheses around that just so it's organized and looks nicer, but they really won't do anything. And all of this has to equal 5x cubed minus 3x squared plus 7x minus 3. So we distribute ax cubed plus ax plus bx squared plus b plus the cx plus d. And so, how many x cubes do I want? How many are on my left? 5. So, I only have one x cubed on my right, so that's pretty nice. A equals 5. How many x squareds do I want? Negative 3. And I only have one x squared term on the right, so that's nice. B equals negative 3. How many x's do I want? 7. So A plus C has to equal 7. Well, you already know what A is, so you might as well just find C, right? A is 5, so 5 plus C equals 7. What's C? 2. And then we want our constants to add to negative 3. So B plus D needs to equal negative 3. Well, we already have B is negative 3. So what's D? 0. That system couldn't have been easier. So going to your final answer, that's going to be 5x minus 3 over the x squared plus 1 plus 2x plus 0 technically, so I'm not going to write that, over x squared plus 1 squared. Good, good, good. And then there's just the long drawn out kind of thing that I showed you yesterday. And then 2 more examples of the same stuff. Right? We're not going to go there, but your denominator could contain a cubic factor. And if it did ever contain a cubic factor, like this would be a nice bonus question to make you think about the concepts, even though we haven't actually done one of those. But if you had a cubic factor, your numerator would need to be, the structure would be ax squared plus bx plus c. It would need to be a quadratic thing. Yes? Okay. So I'm not going to make you go through those 2 examples. Again, I'm going to let you start your homework. There's only 4 of these. And 3s on the packet. Okay. So I'll put those questions up. Page 745, and you can get started. $7.45. I sure do. I had a really great group of kids that brought in the box. Right on the back shelf. Can you grab one of those, please?